118 coming.
Sorry, is that okay with everybody?
I literally just jumped. Wow. Well done. Yeah, sorry. I didn't mean if I assume everybody's okay with this being recorded. So yeah, generics are coming in Go 118. This is something that the very first announcement way back in 2009, within an hour, somebody said, why are there no generics? So they've been very deliberate about trying to bring it into Go. They wanted to make sure they got it right, and clearly they took their time. If you have a browser, you can go out and play with generics now. There's the Go tip playground. Will get you the latest and greatest version, non-stable version to play around with. RC1 landed today. They were Go 118 was supposed to land, stable was supposed to land this month, but they ran into some issues. So there was a second beta, and then the release candidate landed, like I said, just hours ago. So there was a mad dash to update these slides. And then yeah, the final release will be next month. So I know this is going to come off as a bit contrived, but trying to find a good example on how to demonstrate generics. Being a weather guy and dealing with weather data, I thought, yeah, this is perfect. So I have Go code that I've written that takes data from a weather station. And it's like an old RS-232 connection, serial connection. And so the various things coming off of it are in different types. So the weather, wind data and humidity are basically U into 8, because they don't need a lot of the resolution is not that much, but temperature is gonna be in tenths of a degree. So they come in float 64 in the code I've written. So in the past, I've had to have multiple copies of code to deal with this that basically do the same thing. So an example of that would be handling temperature data. Like you can see here, here's just some boilerplate struct code and some receiver functions about not only adding data to a slice of temperature data, but returning max and min readings from a time series, basically. So let's see here. And then as you can tell, this is basically identical, but when dealing with relative humidity, everything's U into 8. So it's more or less a straight copy of doing the same thing. This is a very simplified version of some of the stuff I've written, but it kind of gets the point across. So when you're working with the data, here's the quick main that uses everything. The main itself is pretty straightforward, but the code behind the scenes, there's a lot of duplication. So, and there's other ways you could do that. You could use an empty interface and, do various sniffing around on the type of data you're dealing with in some of these functions. I mean, there's other things you could do, but it all was kind of complicated, I felt. So yeah, it'd be really nice if we could dedupe that code. So that's where the magic of generics comes in. We'll start off pretty straightforward. This is a generic function. And the key here is you're basically setting a constraint on the type that the function can work with. That's the huge telltale. And then a couple examples down here below are working with that generic function. If your data in there is a mixture of things, Go won't be able to infer what that type is. So you can either be explicit in the type, or if it's all the same data, Go will actually be able to infer it. And if I'm going too fast, or if anybody has any questions, just feel free to raise a hand or just speak up. It's pretty informal in here. So yeah, there's this is kind of rehashing what I just said, walking through how that generic function is laid out. The brackets are always your starting place. Like that's how you know when you're looking at the function, whether it's going to support generics or not. And then the pattern is there's an ID and then a constraint associated with that ID. So T being that ID, which is then used further in the function. And then the constraints being like, what do you want to pass into it? Like what does the function support basically? What kind of types? And like I pointed out before, inference and like automatically determining what it is versus being explicit are both supported. So a little bit more about the constraints. There are numerous constraints available. You have the any constraint, which is basically an alias to an empty interface, which is like the most basic thing, but there's not very much you can do with it. Like, comparison operators or order operators, those sort of things. There's an experimental package that you can pull in that has some defined constraints that they're marketing experimental right now, just because since generics are relatively new, those can change. So they just want to make sure that people are aware of that. And that's why they've marked it experimental. In this case, I'm interested in the ordered stuff because I'm looking for max and min temperature and RH, that sort of thing. Or you can even define your own, which becomes, there's an example there of what that looks like. It's just an interface. And you use the same symbol for like the bitwise OR to basically concat like how many things that you want to be able to support with that on your in your constraint. So does that make sense? Yes, John.
So when you're defining your own, does that have to be like built-in types, or can you use your own stuff?
So you can use your own stuff with a caveat. And I actually have an example of that later on. I kind of ran into that. But yeah, more or less, you can define your own type. And then if it's like based off, well, yeah, I'll get to that. It's I will also, I forgot to say this in the beginning, generics are pretty involved on Go. So this is like kind of like I feel like a good starting place, but like I don't cover everything because it can get pretty involved in what you can do with it. But I will hint on like the impact of like bringing your own stuff. So yeah, let's move on. That was a function. How about like what happens if you want to define a struct that supports generics? In this case, again, the bracket is your gateway to a generic implementation of your struct and how it's going to be used. The addition here is that on the receiver functions, you need to be sure to include the constraint ID, but you don't need like the full like ID and constraint. You can just pass in the ID here, but those all become part of the signature to make sure that it is like it all is part of the same struct, the same generic struct. Yeah, this is basically just what I just said. So let's see here. Taking that and putting it to work here. In this case, I like temperature is called it a float 64. RH is a uint 8. And then we're adding stuff like that match up with that. And more or less, this is the same main as before, just using the generic versions of my code. So I got rid of a whole Go file in this, and the output is identical, which was pretty nice. It's been really fun to play with this, honestly. But yeah, so this kind of gets back to what I think what you were asking, Hobbs. In this case, like I wanted to modify temperature, create its own type that could also have some receiver functions that like translate it into like Celsius or like do some other things with it. And in this case, yeah, it's went ahead, created the new temperature type. tried to pass it in. And initially, when I played with this, I thought, oh, hey, this is just compile since I'm just taking a float 64, which was already defined in the constraint beforehand. And no, the compile just like boomed, exploded. But it was pretty nice because the compile error was very straightforward. And they tell you what you're missing. So I feel like I'm putting the cart before the horse here, but that tilde there is really important. And how you fix that is, yeah, if you know that your type is going to, like, if you want other things that are going to use the type in like different definitions, you can put a tilde in front of it, which then tells the compiler to be a little more forgiving when you pass that in. So by saying that tilde float 64 on that interface for the constraint, fixed it up for me and compiled, and it ran just fine. So yeah, any questions on any of that? I feel like I'm going pretty quick. Okay. There's some advanced stuff in here that I didn't cover. Obviously I'm getting close to the end of this. In that you can actually also pass in multiple constraints. So you have basically multiple types on the generic definition. And you just have to make sure that the IDs are unique for those. So T and K would be involved with like how they are handled in the actual function. And the same would apply also to the struct. So there's a lot of like, what's the word I'm looking for? A lot of control over you have, like how advanced these things can be. And then also interface constraints, they can have functions as well. So you can like, this got really like into a realm that I didn't know where to take it with my simple example. So I didn't have any good like further advanced examples to show this. But I linked to this in the slideshow, which I'll get the link out to that on the meetup this evening. But anyway, yeah, so you can really, these constraints, you can really compose them. They can become very intricate and how like what can be used inside of your generic code, which is really cool. So yeah, there's the Go blog had a really good tutorial on this, which is where I started. And then I found on Reddit Go generics the hard way, which is what I ended up doing some other examples from, which also includes some of those interface examples. Actually, that link on the previous slide is to that particular set of markdown docs. And then if for people that are interested in other languages, the section 5 of that, the hard way, does some comparisons to .NET and Java, which was really cool. It's been, forever since I've done Java coding, so it was I was not as familiar with their examples, but if that is a question that you have on how these compare, that's pretty useful stuff. So that's it. I feel like, what was that? That was about 15 minutes. So kind of ran through that. Anybody have any questions on that whole thing? Which is perfectly fine if you don't.
Is the API subject to change until 1.18 actually lands, or is it set?
As far as I know, the actual generics themselves is that what's the syntax is stable in 118, that or RC1. So the examples here all worked. Some of the constraint stuff, like I said, though, is still subject to change, and I think that's going to stay that way past 118. Because my understanding is they're going to start now looking at the standard library after 118 and like modifying code. They're going to like slowly start migrating over, which with Go, that's going to take like quite a few releases before they get there. Matt, I think you're talking, but I can't hear you.
How about now? Is this any better?
There you go. Yeah, I can hear.
Perfect. So anyway, ask I'm familiar with generics in Java. One of the things that's been plagued, like that will always bite somebody in the over time, is that types are erased at compile time. So if you're doing anything with runtime using reflection or any other kind of fanciness, the types that you're working with are no longer there. Everything just gets cast down to an object. I was going to ask how Go compares to that, but I just looked at the hard way, and it looks like, or the generics, the hard way description, and they model it more closely to the way that it works in .NET, and it doesn't, like, it retains types at runtime, so you can actually do interesting stuff with them if you need.
Cool. That's interesting. Huh. That's neat. Well, I will stop sharing. If you want to go, John.
Sure. Thanks, Brian.
Yeah.
1 second. All right. So my topic today is Go embed. Forward a bit here. So there's been many ways for a long time to embed files into your Go binaries. They all use very similar tricks, and they all kind of boil down to packing assets into byte slices and stashing them in your Go files. And some were more clever than others. Some did would append a zip file to the end of your Go binary after it was built. Things like that, tricks to reduce memory copies, but they all boiled down to that. So here's a list of them. Go bin data was one of the first. Go.rice was pretty popular. The Buffalo web framework used Packer. I used that one personally quite a bit. But they all had their own APIs, and they're all just a little bit odd. Here's some examples of the APIs. So this is like a Go bin data on top. Lots of people would use Go generate to kind of run it at build time to get the freshest source files to use. But you see, like, it's got bin data asset, and it's just not something you see otherwise. Packer was a little weird in that you had this API you'd use, but you had to use Packer command line to actually build your binary. So instead of Go build, you'd use Packer. So just weird idiosyncratic stuff. So given this, the Go team decided to move it into Go core. So July 2020, they released a proposal with these goals. So eliminate the need to generate source code, and then don't change the language, and then try not to create any novel new APIs. So just kind of the problems that the previous tooling had. And then actually a year ago yesterday, Go 1.16 was released and really had this features. So Go 1.16 added the embed directive. And there's three main ways that you use it. The first two are very much oriented around single file embedding, and that's what I've got here. So you put your directive and then the path of the file, and then that's above a variable declaration. And then at build time, Go will put the data from that file into that variable. And because it's at build time, if that file's not present, it's a compile error. You get the error then and there. Same thing with the byte slice. It puts it in there for you. So these two are very convenient to use at access time because it's just in the variable. There's nothing you have to do. It's just there. The third option is from a new package they added called embed. So there's embed.fs is a struct. And FS stands for file system there. It's not particularly useful for a single file unless you need to access that file as an IO reader and don't want to have to like put a string in a buffer and use that. So the embed directive accepts wildcards. So you can, that first example is get all the JPEGs in the assets directory and put it in a file system. The second one, it can take multiple paths. So it's getting everything in the images directory and all the JPEG extensions in the assets directory, and they're in the same file store. You can stack them. I don't think that's the correct word, but that's the word I use. So if you have directories one after another, they kind of collapse down onto the variable declaration underneath them. So it's just kind of a way to make it more readable, because if all, 4 of those were on one line, it would be really long and kind of annoying. And then the other caveat of that is that by default, if you include a directory, it will not include anything that starts with a dot or an underscore, to just kind of by default hide what is normally like a hidden file or special files. And then the way around that is to use a wildcard. So if you say directory star, it's going to glob everything and put it in there. So circling back to embed.fs, it implements the FS packages interfaces of FS, readdir.fs, and readfile.fs. And so that allows a lot of flexibility to access the files without adding any new APIs. So like the file walk stuff takes an fs.fs, or my example here is the templates, like the HTML or the text templates use an FS. So we, in this example, we take all the stuff in the templates directory, put it in an embed.fs, and then we use the template package, HTML template package to parse it, and then you can execute it as if it was on your file system. So what can you do with it? Like the primary thing that you're probably going to see is packaging web server assets into the binary so that you don't have to ship them separately. That's primarily what I've used it for. You can use it to embed templates for like your CLI app, or you can do clever things, some of which may be bad ideas. So I'm going to show one of those. So I made a little demo app that shows the different ways that it works, and then the little blob of code that goes with it. Here's an example of one that uses the embed, the embed .fs with the walk, which is a built-in. And so like this is walking all of these meetup files, that just have the description of past Gopher meetups. I'll run the string one again. So my bad idea here is this code blob, and I think it's kind of a cool trick. But so this print code function takes a start line and a stop line, and you'll note they're the same start and stop as we want printed. And so if you go over to utils, you can actually embed your Go source code that you're compiling into your Go binary that you're making, and then use the runtime to get who called this, what file, and then the start and stop line. And then we actually open that Go file and then scan through the lines until you get those 2 lines and then print them out. So it's kind of neat. You can ship all of your Go source with all of your own stuff now if you really wanted to. But yeah, and obviously it's not great because if an import changes, these lines are going to change. But it just shows I guess the flexibility of it. Yeah, that's it. There's not a lot to it. I put the source code of that out there on GitHub, and it's got every way that I could figure out to call and use the embed directive on it. So anybody have questions? Cool. All right. So yeah, that's all there is to go over. Unless anybody has something they want to share or talk about, or
That pun intended. Go over.
it was not completely unintentional.
Finger guns.
Cool. All right. Well, short and sweet this time. Hopefully we can do this again soon. And if you have something you want to talk about, definitely let us know on Meetup. Otherwise, we'll have to force Cody and Matt to do it.
We already can't, yeah, we can't trust me to do anything while operating, a microphone. So somebody else needs to do this.
Cool.
We threw in a lapel mic that we sent to you in the mail. Would that like sweeten the deal?
I mean, like a real nice lavalier, or just hold the snowball like around a chain on my neck.
There you go. You have a 3D printer. Could we like 3D print like a necklace, a snowball necklace for you?
There's nothing that's more comfortable than a PBA plastic just molded into a giant hula hoop around my neck.
Fair enough.
All right. Well, see you, everybody.
Thanks for setting this up, guys. This is great.
Yeah. Good to see you all.
See you all.
Later.